nearing the end of my videos on the different rules. But finally, we're officially getting to the chain rule. Okay. Our chain rule, if we have a composition of functions, so if we have an inside function and an outside function, let me actually choose purple for my inside. And I've already been spiraling in our chain rule in hopefully a way that I think makes more sense. This is actually more the way my original calculus teacher when I was a senior taught it to me. And I lost it in between the many years that it's been since I was a senior. But if we have an outside and an inside function, it's the derivative of the outside with the inside times the derivative of the inside, which I've been calling dx. My derivative of my inside has now become dx. So looking at this first example here, oh, I forgot to write examples. The derivative of 3 times 3x minus 4 cubed. Well, we can just think of this as a power rule originally, where our n equals 3 for our outside function. Oh, actually, let me call this whole thing f, and this inside. Actually, I don't want to call it g now. I want to call it what we've been calling it, dx. So f equals 3x minus 4 all cubed. F prime would just be 3 times 3x minus 4 squared dx. And in this case, our dx is not 1. Our dx, the derivative, this is where I'll start using purple. Dx is going to be 3, because the derivative of 3x minus 4 is 3. And now putting everything into place, we have 3. Let me choose a different color for this 3 actually, so it'll be clear. We're just putting that 3 that I don't want to forget, times f prime of g of x, which is just what we have now. It's 3, 3x minus 4 squared dx. Or 3 times 3x minus 4 squared times dx, which is the derivative of our inside function. And now making this cleaner, we're just going to get, well, I'll do it piece by piece. We have 9, because 3 times 3x minus 4 squared dx, and we said our dx is 3, so now 9 times 3 is 27. We get 27 3x minus 4 squared. And there's our derivative of the first one. Do this just to separate the problem out a little bit. Okay. And now I'm going to sort of slow down on my denoting stuff, because now that we're doing it like this, I don't need to write it out as much anymore, because my outside function is cosine. The derivative of cosine is negative sine, and then my inside stays the same, times dx. And our dx is just the derivative of the inside. Well, the derivative of the inside, 4x squared, would just be 8x. So we have negative sine of 4x squared times negative 8x. And then just making that cleaner, we have negative, why did I say negative 8x? What am I doing? Times 8x. positive 8x. So we have negative 8x sine 4x squared. And that's it. Chain rule on the next one. Here again, actually I have a constant out front. Just put that in green so I don't forget it. My f will specifically be everything but the constant, 2x cubed minus 2 to the 6th. Power rule, n is 6. 6 minus 1 is 5 times dx. And our dx, in this case, is the derivative of the inside. 2x cubed has a derivative of 6x squared. Then we just put everything in place. We have f prime. So we have, all right, let me not forget my constant. 5 times 6, 2x cubed minus 2 to the 5th times dx, which we said was 6x squared. We can clean this up. 5 times 6 is 30, times 6 is 180. So 180 x squared, 2x cubed minus 2 to the 5th. Next example, this is getting into sort of a mixed one, because we're not just using the chain rule here. We also need to use another rule. Hint, we have one function being multiplied by another function, so surprise, surprise, we now need to use the product rule as well, which, just as a reminder, if I think of it in terms of f and g, that's going to be f times g prime plus f prime times g, or something like that. Okay. And now we have f equals 3x minus 2 cubed. This is our power rule. F prime equals 3x minus 2 squared times dx. Well, what is our dx in this case? The derivative of our inside is just 3. The derivative of 3x minus 2 is just 3. And now we have g equals 4x minus 1 cubed. G prime is going to be power rule again, 4x minus 1 squared dx, and then dx is going to be 4, because our derivative of 4x minus 1 is 4. Start putting things into place. We have 3x minus 2 cubed times g prime, which is 3 times 4x minus 1. I'll go ahead and substitute in the dx. The dx is 4 plus f prime, which we said was 3 times 3x minus 2 squared dx. Dx we said was 3 times g, which is 4x minus 1 cubed. Now we're just going to make it look pretty. We have a coefficient of 3 and 4. That's going to be 12. So we have 12, 3x minus 2 cubed, 4x minus 1 squared, plus, looking here, I have a 3 and a 3. That's 9. 3 times 3 is 9. 3x minus 2 squared, 4x minus 1 cubed. We could keep simplifying further, but it looks hard, so I'm not going to. I don't have another example written, but I actually do want to do one more example that I think will be helpful for a lot of us. If we have cosine squared of, let's say, 3x, here we get into a little bit of a sticky spot. because, well, our f is cosine squared of 3x. What rule are we going to use here? Well, I'm actually going to rewrite this to make it look a little nicer. Let me actually go down instead of to the side. Equals cosine of 3x all squared. Well, now this just looks like our power rule. F prime equals 2 cosine of 3x. What is 2 minus 1? That's just 1, so it becomes invisible. Times dx, which in this case, this dx, our inside, is going to be negative sine of 3x, again, times dx, which what is the inside of our function? What is our argument? 3x. So our green dx is going to be 3. So now we need to start putting everything into place. We have 2 cosine of 3x with our red dx, which is, so times negative sine of 3x times our green dx, which is 3. And then just moving everything, I have a 2, I have a negative, and I have a 3. That's going to be negative 6 cosine of 3x sine of 3x. And there's our derivative there. I hope me explaining this way was helpful and does not confuse you more. But if it does confuse you more, I'll go back to the other way with our outside inside.